Hello everyone, welcome to this lecture video. In this lecture video, we are going to discuss deadlock avoidance. In this lecture, deadlock avoidance, we have the banker's algorithm. It's one of the famous methods to avoid the deadlock. In this banker algorithm, we have a resource type with many instances. In the previous lecture video, given introduction about the banker's algorithm, how the clients are asking for loans and to an agreed limit. The bankers know that not all clients need their limits simultaneously. All clients must achieve their limits at some point of time, but not necessarily simultaneously. After fulfilling their needs, the clients will pay back their loans. For example, the bankers knows that all for example, Adam, Eve, Job, Mary, 4 clients need 22 units together, but he has only total 10 units. So, available 10, available only 2, available 1. So, it will be allocated based upon the client only with available resources. So always keep so many resources that satisfy the needs at least one client. So bankers algorithm concept is always keep so many resources that satisfy the needs of at least one client. So multiple instances, each process must priori claim maximum use. Each process must priori claim maximum use of a process. When a process requests a resource, it may have to wait. So when a process gets all resources, it must return them in a finite amount of time. For example, in this example, we have the banker algorithm. 5 process P1 throw P5 process PO throw P4. 3 rows 3 types A. 10 instances, B have 5 instances, C have 7 instances. Snapshot at a time TC. So allocation P0, P1, P2, P3, P4. Allocation ABC, maximum value of ABC, need of ABC. Total ABC 10, 5, 7, allocated to 7, 2, 5. So this term is unsafe state since the sequence. So value will be given here for the banker's algorithm process. So from this we can have the solution for each client will be engaged and will be provided the resources. So deadlock detection allows system to enter deadlock state. Detection algorithm recovery scheme, we have the deadlock detection. We can handle the deadlock by also deadlock detection also. So here deadlock detection is a detection algorithm. We having work equal to work plus algorithm allocation equal to finish equal to true. Go to step 2. Step 2 is a finding index of such that finish of false. If request less than equal to work. If no such I exists, go to step 4. So finish equal to false for the I less than 1 less than n, then system is in deadlock state. Moreover, finish of I equal to false, then pi is deadlocked. So algorithm requires an order of O of m into x n square operation to be detect whether the system is in deadlock state. So for example, this detection algorithm can having this kind of process. So deadlock detection we are using here. So algorithm for the example for detection algorithm is by we have the some example value of P1 to P4, 7 instances, and B having the 2 instances and C having the 6 instances. So for requesting the deadlock detection from this state of system, we can reclaim the resource by holding the hold and also having these kind of things. So the detection algorithm usage, when how often to invoke depends upon how often a deadlock is like to occur. How many processes will need to be rolled back, one for each disjoint cycle. If a detection algorithm is invoked arbitrarily, there may be many cycles in the resource gap, and so we are not able to tell which of the many deadlock process caused the deadlock. So deadlock detection algorithm, we can having these kind of things. So deadlock detection, we having the one deadlock has been detected. Some strategies needed for recovery. The various approaches of recovering from deadlocks are process transmission, termination, resource permission. So resource allocation graph and also corresponding wait for graph. So deadlock detection, we can have the deadlock detection in the process way. So resource allocation graph graph and wait for a graph. We'll have the in the following example. So once deadlock has been detected, some strategy needed for recovery. The various approach of recovering from deadlocks are termination, process will be terminated, or also resource preemption. These two things will be used for deadlock detection. So wait for a graph is a second thing, residual allocation graph in the first one. So in this way we can have the deadlock detection. So deadlock recovery also having in this thing. So we have discussed the plenty of things about deadlock detection in the previous in this lecture video. We can have the deadlock recovery in the how we can handle the deadlock by deadlock recovery in the next lecture video. Thanks for watching. Hope you all understand what about the deadlock we can handle by using the deadlock detection and methods followed in the deadlock detection by also the banker's algorithm used, how using the banker algorithm efficiently for avoiding the deadlock. So it can be deadlock detections. Thanks for watching. Thank you.